Okay, in the last lesson of the unit, solving more difficult trig equations. So we're going to have to use some trig identities here. So they include our reciprocal functions. They include our Pythagorean identity of cosine squared of x plus sine squared of x equals 1, as well as really any other thing you've learned to solve algebraic expressions this year. Okay, we'll look into factoring. We'll be squaring. We come back to the unit circle, our exact value chart, so really brings everything together. All right, our first four problems, the domain is in degrees, so solve for where the tan squared of theta equals 1. So to get tan alone, I take the square root of both sides. I get tangent of theta equals positive or negative 1. Now I'm only going one rotation around the unit circle. But I know my tangent is equal to positive 1. That'll be quadrant 1 and quadrant 3. Tan of theta is going to be equal to negative 1 in quadrant 2 and quadrant 4. I'm going to set all these up, including non-calculator and calculator. You're going to solve them all. So if you want to pause the video now, you need to be able to determine your reference angle and then find all those angle measures in each of the quadrants. This is a non-calculator problem. Okay, next, secant squared of theta equals 9. I take the square root. I get secant of theta equals plus or minus 3. Secant is the reciprocal of the cosine function. So this will be where the cosine of theta is equal to plus or minus 1/3. Okay, so I know my cosine is positive in quadrants 1 and 4. And I know my cosine is negative in quadrants 2 and 3. Now this is a calculator problem, so make sure your mode is in degrees. And I would suggest to find your reference angle. So as I taught it, take the inverse cosine of, always make the angle measure, the exact value rather, positive. So find inverse cosine of 1/3. This will be your reference angle, and then use that to find your four answers. Okay, now looking at this, you have two trig functions here. If you think about the way this is set up, so if I were to take, let's just say x, and substitute it wherever I see the sine of theta, I would get a quadratic form. Okay, so now I have this form 6x squared minus 7x plus 2 is equal to 0. So now these forms should be much more recognizable and factorable. You can verify that the factors are 3x minus 2 and 2x minus 1. So setting each factor equal to 0, I get x is equal to 2/3, and then I get x is equal to 1/2. But remember, we're not solving for x, we're solving for the sine of theta. So I have to go back and make that substitution. So now sine of theta is equal to 2/3, and sine of theta is equal to 1/2. This is a non-calculator problem. Okay, so within my domain of 0 to 360 degrees, I'm going to have a quadrant 1 and a quadrant 2 angle. Sine of theta equals 2/3. This is a calculator problem, but it's the same quadrants. So sine is positive in both Q1 and Q2. All right, so again, you are solving each of these either as we go along or at the very end, but you need to have answers for all of them when you come to your next class. 6 sine squared equals 7 minus 5 cosine theta. Okay, first things first, let me get my equation equal to 0. Add 5 cosine of theta, subtract 7. All right, it's a quadratic form in that I have a squared and a single, but notice that my trig functions are not the same. So we cannot make a substitution and say either x is equal to sine theta or x is equal to cosine theta, because it would still leave my equation in terms of one trig function. This is where our Pythagorean identities come into play. So we know cosine squared theta plus sine squared theta is equal to 1. Now, looking at the original, I'm going to make a substitution for sine squared of theta. So subtracting cosine squared theta from both sides. Now, wherever I see my sine squared, I can replace it with 1 minus cosine squared of theta. Now I'm going to fill back in all the pieces. Now before moving on, I have one trig function that's the same for the entire equation. So now I'm going to distribute. I'm going to combine like terms. And before I even attempt to solve it, I like my lead coefficient to be 1, or excuse me, to be positive. So I'm going to take everything and divide each term by a -1, just to get that to be equal to a positive. Now I have my quadratic form. So now I can make the substitution and say that x is going to be equal to the cosine of theta. So I get 6x squared minus 5x plus 1 is equal to 0. Now again, I'll let you verify that these are correct. So 3x minus 1, 2x minus 1 would be equal to 0. So my two values for x are 1/3 and 1/2. They end up being 2/3 and 1/2, okay? So going back, now I have cosine of theta is equal to 1/3 and cosine of theta is equal to 1/2. Same deal, the 1/2 is a non-calculator problem. The 1/3 is a calculator problem. Same quadrants, however. This will be Q1 and Q4, because in those two quadrants, the cosine function is positive. And then this will be Q1 and Q4 for the same reason. I'm sorry, I don't know why it keeps doing that. All right, now, first things first, notice that we're changing the domain. So now all of our answers are going to be in terms of radians. So first, I'm going to try and simplify this any way I can. I know my tangent function is equal to the sine of x divided by the cosine of x. So now on the left-hand side, I see my cosines cancel, and I'm solving the equation sine x equals cosine of x. So now this is a non-calculator problem. Think about this. Where do the sine and the cosine equal each other? They equal each other at pi/4, because both trig functions have an exact value of square root of 2/2. But depending on the quadrant, one can be positive, one can be negative. So in Q1, both the sine and cosine are positive, so that'll be one solution. In Q3, both the sine and cosine are negative. One more than the bottom. So 5 pi/4 is my second answer. Okay, so both of these answers are where the sine equals the cosine. Q1, both are positive. Q3, both are negative values. All right, first things first, to get my equation equal to 0. Now I can factor out a sine of x, leaving me with sine x minus 1 equals 0. Now I have sine x equals 0 and sine x equals 1. So continue to solve. Our mode is now in radians. This is non-calculator. You're looking at one rotation of the unit circle in radians. Okay, so you have spent a whole lot of time solving problems like this. All right, number 7, 2 cosine squared x equals cosine x. So I'm going to subtract my cosine x from both sides. I'm going to factor a cosine x out, and I get 2 cosine x minus 1 equals 0. Okay. Cosine x equals 0. Cosine x equals 1/2. Same deal. Non-calculator. Look at your exact values in your unit circle. Now, number 8. Number 8 is actually a lot like what we got for number 5. But this is one case where I don't want my equation to be equal to each other. So I'm actually going to subtract the cosine. Now we're looking for where sine and cosine are opposite of each other. So we still know that our reference angle is at pi over 4 because both exact values are square root of 2 over 2. But now I need them to be opposites. So quadrant 2 is where the sine is positive and the cosine is negative, so they're opposite of each other. And then in quadrant 4, that would be my other answer because the cosine is positive and the sine is negative. Okay, because an equivalent equation to that would be that negative sine x equal cosine x. So these are your two solutions where they're opposites. The other answer was where they were the same. All right, number 9. Two different trig functions, but cosecant is a reciprocal function. So I'm going to rewrite that in terms of sine. Okay, we don't want sine in the bottom. So I'm going to take my equation and I'm going to multiply the entire thing by sine of x. Every single term. So think about distributing. Sine of x times 2 sine of x would give me 2 sine squared of x. Sine of x times negative 1 would give me negative sine of x. Sine of x times this fraction, the signs would cancel, leaving me with a minus 1. Okay, great. Now it fits that quadratic form. Right, so now I'm going to let a equal sine of x. So I have 2a squared minus a minus 1 is equal to 0. All right. So factoring that, we would get 2a plus 1 times a minus 1. And maybe some of you are not going to need to make this substitution. You'll be able to do these problems and sort of see them right away. I get a is equal to negative half, and maybe not right away, but you can keep the sign, you can keep the trig function in the expression as you factor. So now going back to my substitution here, I get sine of x equals negative 1/2. Sine of x equals 1. Both of these are non-calculator problems, so you're going to solve those. Okay, now in the interest of time, I'm going to leave 10, and this is what we'll begin our next class with. So you have plenty of problems to go back and solve. There's a lot more non-calculator than there are calculator problems. Okay, that'll do it.